Okay, let me take up the DPSK. Yes, anyone can say what is DPSK? I think I have told what is the theory behind that. Have I told or not? DPSK. Yes, people should say yes or no. Have I told theory what DPSK is? For saying yes or no also, people don't open up your mouth. Yes, have I told what is DPSK? ಮಾತನಾಡ್ರಿ ಹೇಳ್ರಿ what is DPSK? I told theory. We have already discussed that in the previous semester. Even then, I told in brief what is DPSK. That is a differential phase shift keying. Okay, the incoming binary data will be XNOR. Okay, by taking initial bit as 1 or 0. So output of that XNOR, okay, we are going to do the PSK modulation. So here 0 will be represented with 0 degree and 1 will be transmitted with 180 degree. Okay, that is what the differential phase shift keying is. I will go to Simulink. Okay, you all can open the Simulink. I will share that screen. Just open up your Simulink. Yes, is it opened? Hello, open the Simulink.
Sir, it's still loading, sir.
Still loading.
Still loading, sir.
Okay, okay. Once it is opened, you tell me. I will tell what to do.
Open. Open, sir.
Open now. Okay. Okay, still in my system it is. Yeah, you can take. I will tell what are the components to be taken. Hope you are able to see this window, no? Is it possible to see my PPT?
Yes, sir.
Yes, sir.
Yeah. In that, see, one is Bernoulli binary generator. What we have taken for QPSK, no? You can take that by going to communication toolbars. Then modulation. Their sources is there, no? you'll get that, right? Bernoulli binary generator. Then you can take the logical operator, that is uh, logical operator, which is XNOR gate. You can take XNOR gate. Okay, I will open. I will open DPSK. Already I have done. I think. Yeah. Yes. Hope you have taken Bernoulli generator. Hello.
Yes, sir.
Uh,
Yes, sir. We have
I
taken
told you
Bernoulli
to
by.
take XNOR gate. Okay. Oh my God.
So where to find XNOR gate?
XNOR gate. Go to logical operators, no? Logical
Okay,
operators.
sir.
Uh, and even delay element also you can take.
Sir, I didn't find XNOR, sir.
You didn't find XNR.
So, way to find a Bernoulli generator, sir.
Go to communication toolbox. Communication toolbox is there now. After going to communication toolbox, click on modulation. Okay. If you click on, yeah, there here communication sources are there. Go to communication toolbox, there communication sources. You click on communication sources, then first one is a random data sources. So if you click on random data sources, you will get that Bernoulli binary generator. Hope got it?
Yes, sir.
Yeah. Okay. Then I think she was asking about a logical operator, no? Go to logical, here is there, right? Even you can search. The search is there, no? You can there write XNAR. XNAR. XNAR logical operator.
So when we click on AND gate, we get options to change the logic.
Okay, fine. Yeah, in the logical bit operations, in your logical is there, right? Logical operator is there, right? You can take that. Yeah, as correctly she said, if you double click on that, it will ask what type of AND gate. And R, NAND, XNOR, XNOR, and all is there. You can select XNOR. Okay. Is that fine?
Yes, sir. Thank you, sir.
Then similarly, this delay element also, you will get, I think, either in commonly used blocks. Yeah, delay is there here, right? Hope got delay. So take delay, then this is constant.
Sir, we can find delay in the commonly used sources, sir. Commonly
Common
used blocks.
source. Yeah, commonly used block, it is there, Z inverse delay. Yeah. Constant is also there, only you can take it constant. Then product, then sine wave, then one switch. That's all. Okay, connect as per this. So this will generate binary data, Bernoulli binary generator. So one input is that to the XNOR gate. So another input is what to the XNOR gate with 1 bit delay. So delay element is there. For that output of XNOR gate is the input to delay element. Then output of the delay element will be is the another input to the XNOR gate. Okay, then output of that XNOR gate, okay, will be connected to middle of the switch. Then here, so I'm inversing the, so right, I'm making constant as -1, here sinusoidal signal, that product will be connected to first switch. switch terminal first terminal. In the switch first terminal. Okay, for the third terminal of the switch, I am connecting the carrier. Output of that is the DPSK waveform, what I can say. Yes, able to see. Now I made big. Yes, hope able to see. Yeah, set. You click on this scope. First, you select the scope parameters. Four are there, right? One, two, three, four windows. Make four windows and then you make the layout. So these things are proper, then everything will be proper. Yes, hope the setting is done. Means four windows because I would like to see four signals. One is my input binary data. Then second one is I have connected output of XNOR gate. Then the delay element output also connected. Then next is the DPSK. Hope this is clear. So XNOR output is connected as input to the delay element. Output of delay element is connected as input to XNOR gate. I wanted to see that also. So four things. First window is binary data. Second window is delay element. Third one is output of XNOR. And fourth one is my DPSK signal. Okay. And even you can set the style also for different colors. Yes, able to set everything. Hello, is it done? You can save this and then you can run it and see what is the output if it is done. Yes, able to get the output. So this is what I am getting. Okay, this is my input binary sequence, and this is the 1-bit delay version of that. Then this will be XNOR output, and this is my DPSK waveform. See, if I compare here, see XNOR of these two. I think here it is 0, this is also 0. So 0 XNOR with 0, what I will get? 0 XNOR with 0. Yes, anyone can say no, what is the output of 0 XNOR with 0? Hello? 0 XNOR with 0. Huh?
1, sir.
1, right? So that is
1.
what is there here, 1. Right, next is what? 1 is there here and here 0 is there. So 1 XOR with 0, 1 XOR with 0, it is 0, right? Then next also 0 is there, here 1 is there. So 0 XOR with 1, it will be 0. So next is what? 0 is there, here 0 is there. So 0 XOR with 0, it is 1. So like that I am getting the sequence. As I said, 1 will be transmitted with 180-degree phase shift and 0 will be transmitted with 0-degree phase shift. So that we are able to observe here, right? So first one is 1. So that is why I am getting 180-degree phase shift. Next bit is 0. So it starts with 0 degree sinusoidal signal. Next bit is also 0. It starts with 0 degree. So next bit is 1. So it is with 180 degree. Next bit is 0. Starts with 0 degree and so on, right? Yes, is this clear? Yes, I am asking, is this clear?
Yes, sir.
Yes, sir.
Yeah, I think now it is still clear.
Yes, sir. Can you show the circuit window, sir? Yes, sir. Clear, sir.
I think I will change the color of second window. Delay. Yes, hope able to see now. First one is my binary data from the Bernoulli generator. Okay. Second one is 1-bit delay version. And this one is third window is XNOR output. Fourth window is my DPSK signal. So XNOR of these two, right? 0, 0, it will be 1. Next is 1 0, it will be 0. Next is what 1 0, it will be 0. Next is 0 0, it will be 1, right? Then 0 1, 0. Then 0 0, it will be 1. Right? Next is 1 1, it will be 1. So next, I think 3 4 bits, it will be 1 only. So as I said, 1 will be transmitted with 180-degree phase shift. 0 will be transmitted with 0-degree phase shift. That is what is happening here. Okay. Hope everybody has got this answer. And even this clarity will be there if you go to view, make it auto. If you make it auto in the configuration properties, if you make it auto, this maximize access and access scaling, you will be able to see this proper signal. Otherwise, it will be small. Yes, if everybody has done, then I will go to the next one.
Sir, can you show the circuit window, sir?
Circuit window,
is
yeah.
not done, sir.
This is the circuit window. Very simple. Only XNOR and delay element, then one switch, then one constant and sinusoidal signal. So whenever, even I think I set threshold here 0 only. Okay, in the switch. And for the sinusoidal signal, you can set amplitude is 5 volts, frequency I set at 2 pi into 2, then sample time is 0.01. Okay, I think rest of the things are nothing to worry. Constant I set -1, then delay also, you don't have to set anything. It will take the default value, that is initial condition 0, sample time is -1. And even I think here also I made auto. Yeah, here I set initial seed as 40. Yeah. Even if you make it auto also, you'll be able to see the same thing, not an issue. Is it fine? Yes, is it possible to post in chat box your results? Hello. You all can post your result in chat box, na? I'm asking you people to post your result in the chat box. You can take the print screen and put it in the chat box. Instead of asking me to present, okay, I can see it here only now. Hope you are able to hear me. Yes, Chaitra.
Yes, sir.
Have you got the output?
No, sir, I
Sir,
was not able
unable
to
to
open the scope.
from
Huh?
switch to scope.
Huh? What Akshata? Yes, Akshata, what is your doubt?
Sir, I'm not able to connect the switch to scope, sir, the third port.
Why? You have taken four ports, no? For
Don't know, sir. Can I present?
not present money. Yes, what about others? Those you have got, you can post your result in the chat box. Yes, quickly answer your attendance in the meantime. Abhilash, Aditya Datta.
Yes, sir. Sir, what all should we configure for sine wave?
Sine wave, I told them an amplitude, you can set any 5 volts. Then frequency,
Sir, I'm not getting that square wave, sir.
huh?
Like in your system, there's an icon square above a square. I'm not getting like that, sir.
Like this, huh?
Yes, sir. Yes, sir.
Yeah, you will get, man. You just double click on this. You see time based, you select. Sine
Yes, sir.
is
Selected.
time based, use simulation time, amplitude 5 volts, then frequency 2 into pi into 2 I have done. Okay, since it is radians per second, that is I have written 2 into pi into 2. Then sample time is 0.01.
Yes, sir. Now I got it. Yes, sir.
Uh,
Okay, sir.
yes, Aditya Patel, Aishwarya,
Yes, sir.
Akshata, Aman Sharma,
Present, sir.
Present,
Anup
sir.
Ganesh, Anup. Anup is not there. Chaitra, Saujanya,
Present,
Chandan,
sir.
Chandan, Deepak Tiwari,
Present, sir.
Gautam,
Present, sir.
Kavya, Keshav
Present,
Kanya,
sir.
Yes, sir.
Keshav Venkatesh,
Present, sir.
Kanya,
Present,
Madhura,
sir.
Meghana,
Present, sir.
Mailaram Sri, Mailaram, Nandish Reddy, Navya, yes, Navya is not there. Yes, Pranav, Ashwin Kumar, Ritu,
Present, sir.
Ritika,
Present, sir.
Sai Lakshmi, Sai Lakshmi, not there. Saurav Srinivas, Shreyas N. Rao,
Present, sir.
Siri, Siri N. Rao, Sonali,
Yes, sir.
Srikanth, Sudarshan,
Present, sir.
Suhas Reddy, Sushmita,
Yes, sir.
Teja,
Present, sir.
Vandana,
Present, sir.
Vidu,
Yes, sir.
Gagana,
Present, sir.
Gana,
Present, sir.
Arshita, Kusumakar, Kusumakar, Rakshita.
Present, sir.
Yes, I asked you people to put in chat box. I'm not finding any of yours. Result why? Yes, what is the problem in putting your screenshot in the chat box? Is there any difficulty? Hello, you people only should respond. Is there any difficulty in putting your results in this chat box? Hello?
No option, sir.
Huh?
There's no option to put the screenshot.
Exactly. You take screenshot, print screen. Okay.
No, sir,
Like,
in the chat box, there is no option to put, sir.
no. See, if you go to chat box, then you can put there. You take the print screen. Okay. Control C, Control V. You do Control V. That's all. I think you should be able to do. Let me try from my side. Okay, it is not taking. Hmm? Maybe the capacity is less. Then what you will do? How do I understand you people have done? At least you can say got output yes or no, na? In that sense, everyone. Yes, you should turn on your camera and present it, or you should acknowledge in the chat box that you have got the output. Any one thing you can do. Yes, hope you are understanding no, what I am asking. Either you can present or you can say yes in the chat box. No, at least doing, got. Okay, at least I will be understanding. Okay, still how many are doing and how many have got the output.
Sir, can I present, sir?
Well, 1 minute. Somebody is asking, can you show the scope configuration? I will show. Scope configuration is nothing, man. So four windows. Make four windows. Go to this layout. Select these four. Okay. Then do the process as usual. Then if you go to that configuration, you can make that open it simulation start. Then make everything auto. Okay. Then similarly time display and all. You can set different colors. So if I made everything same color, then you would not be able to make the difference. That is why given different colors. Yeah, if this is done, yes, is that fine? Aditya, that
Sir, I'm not getting output, sir. No, one second.
Aditya, that you're not getting output.
No, sir, I'm getting
Yeah.
three blank lines, sir.
What's the blank you're getting? When you can share.
Present, sir.
Uh,
So like this I'm getting.
You show the scope configuration, what you have done. Layout is fine. 4 you selected. 4 windows are there. More than 4 is there. Okay. Time you might have set seconds. No? Next time. Yeah, select seconds. Apply OK. You can show time axis label. You can so that it will display. Yeah. Then display. Yeah. Here you need to set CY minimum 0.1 is 0.9 is there. You can make that maybe 10 volts. Minimum minus 10 and maximum plus 10. Yeah, minimum minus 10, maximum plus 10. And you make that show legend. You should write amplitude. Y-axis is amplitude. Down. Y label is there, no? You can make Y label is amplitude. Amplitude. Okay. No, you. Okay. You should press apply and OK for every channel. Apply and then OK, OK. Like that you do for all.
Okay, sir.
But channel 1, 2, 3, nothing is displaying for you, data, binary data.
Yes, sir. That's why, sir.
Have you made that Bernoulli binary generator? That seed is initial seed is 40 or 48, something like that. Yeah, okay, fine. That is fine. Okay. Now you check. Go to view, scope only. View. Their configurations. Yeah, here you make both auto. No man, configurations first. Main. Go to main. Yeah, make both auto. Yeah, both auto. Apply, then okay. Yeah, you can set other windows. This one also display. One is there. No, make it 10. Everything. You should take this a tick box. Show legend. Show legend.
Still, these windows are straight lines, sir. It's not showing
Straight line. Okay. You run now. You do everything and then run it. There only is there simulation. Go to simulation. Run it. See the difference. No.
Yes, sir. Yes, sir.
But still your first 3 windows output you are not able to see anything. Only straight line you are getting. I think something mistake is there. What to create a connection, click port, terminator, something is displaying in your this one.
No, sir. It's just a tip, sir.
Okay, tip.
Sir, it is showing the same way for me also, sir.
It is not showing 1, 2, 3 windows.
Means it's showing, sir, the single line.
Single line ಅಲ್ವಲ್ಲ ಹಿಂಗ್ ಬರ್ಬೇಕಲ್ವ ನನ್ ಬಂದಿದ್ದಲ್ಲ ಈ ತರ
ಸರ್ ಅದು ಬಂತು ಆಮೇಲೆ ರನ್ ಆಗ್ತಿದೆ ಅನ್ಸುತ್ತೆ ಸರ್ ಆ ವಿಂಡೋಸ್ ಟೈಮ್ ರನ್ ಆಗ್ತಿದೆ ಅನ್ಸುತ್ತೆ
ಬಟ್ ಅಷ್ಟೊತ್ತೇನು ರನ್ ಆಗಲ್ವಲ್ಲ ಇಟ್ ಈಸ್ ನಾಟ್ ದಟ್ ಬಿಗ್ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಬರುತ್ತೆ when I made it manual it has come auto, it was displaying properly. What about others? Yes sir. Aditya Datta and Gautam is saying problem. They are not getting first 3 windows. That binary data. What about others? I am asking. Sushmita, are you getting?
Sir, I'm doing, sir. I'll tell you in some time.
Sir, I am presenting, sir.
Present. ಅದೇ ನಿಮ್ದು ಅದೇ ಪ್ರಾಬ್ಲಮ್ಮೇ. ಫ್ರೀಕ್ವೆನ್ಸಿ ಏನು ಅಷ್ಟು ಚಿಕ್ಕದಿದೆ ಅಂದ್ರೆ ಕಡಿಮೆ ಇದೆ, ನಂಬರ್ ಆಫ್ ಸೈಕಲ್ಸ್. ಏನ್ ಮಾಡಿದ್ಯಾ? 2 × 0.2ನೇ ಮಾಡಿದ್ಯಾ? 0.01 ಇದೆ ಅಷ್ಟೇ. ಟೈಮ್ ಬೇಸ್ಡ್ ಕರೆಕ್ಟ್ ಆಗೇ ಇದೆ. ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಇಲ್ಲೇ ಹೋಗಿ, ಇಲ್ಲಿ ಸ್ಕೋಪಲ್ಲಿ ಹೋಗಿ, ಸ್ಕೋಪಲ್ಲೇ ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ. ವ್ಯೂಗೆ ಹೋಗಿ, ಸ್ಕೋಪಲ್ಲೇ ವ್ಯೂ ಕಾನ್ಫಿಗರೇಷನ್. ಯು ಮೇಕ್ ಇಟ್ ಆಟೋ. ದಿಸ್ ಒನ್. ನಾವು ಅಪ್ಲೈ ಅಂಡ್ ಓಕೆ. Apply OK. It will change. Run it. So it should change. Go to simulation and run it. In the scope only. In the scope only you can go to simulation. That simulation is there. No? There also you can run. Simulation is there, man. Now it is running. Yeah. ಅದೇ ನೀನು ಬರ್ನಲ್ಲಿ ಬೈನರಿ ಇದರಲ್ಲಿ ಇದನ್ನ ಚೇಂಜ್ ಮಾಡಿಲ್ವಾ? ಇನಿಷಿಯಲ್ ಸೀಡ್ 40 ಅಂತ ಸೆಟ್ ಮಾಡಿಲ್ಲ? ಮಾಡಿದೀನಿ. ಔಟ್ಪುಟ್ ಡಾಟಾ ಟೈಪ್ ಡಬಲ್ ಸ್ಯಾಂಪಲ್ ಅದೆಲ್ಲ ಚೇಂಜ್ ಮಾಡಿದೆಯಲ್ಲ. ಸ್ಯಾಂಪಲ್ ಟೈಮ್ 40 ಅದೆಲ್ಲ ಯಾಕೆ ಚೇಂಜ್ ಮಾಡಕ್ ಹೋದ? ಯು ಮೇಕ್ ಇನಿಷಿಯಲ್ ಸೀಡ್ is 40 man. That's all. Rest all you keep as it is. Whatever by default data is there, no? You keep that one only. That is one only you keep. Okay, sample time, samples per frame, you keep one only. ನೀನೆಲ್ಲ ಚೇಂಜ್ ಮಾಡಿದ್ಯಾ ಪ್ಯಾರಾಮೀಟರ್ಸ್, ಅದಕ್ಕೆ ಅದು
Sir, how to configure for scope?
ಬಂತು ನೋಡಿ ಅಲ್ವಾ? ಸ್ಕೋಪ್ ಹೆಂಗ್ ಕಾನ್ಫಿಗರ್ ಮಾಡ್ತೀರಾ? ಇದೆಲ್ವಾ ಲೇಔಟ್. ಫಸ್ಟ್ ಯು ಕ್ಯಾನ್ ಸೆಲೆಕ್ಟ್ 4 ವಿಂಡೋಸ್. ಯು ವಾಂಟೆಡ್ 4 ವಿಂಡೋಸ್, ರೈಟ್? ತೋರಿಸ್ತದ ನೋಡಿ. Go to layout. You first select 4 windows. So you'll get 4 windows, right? After that, go configure properties and do as usual. Open simulation start. You can put tick mark. Means as soon as simulation is done, it will open this graph. Okay, make everything is auto. Maximize access scaling. Then go to time, make there it is seconds, time minute. Rest of the things you keep this auto wrap and all. Then display is all left to you, how you wanted to display. Okay, 4 windows are there. No, for each of the windows you can select y-axis label and y limit, maximum, minimum and all.
Okay, sir.
For display, for all of the things we can keep y minimum is less than 0. Okay, that is minus 0.125 is there, that is fine. Means it is like unipolar code what we are displaying. Unipolar NRZ. ಏನು? ಹಾಕಿ ಕಳ್ಸಿ. Yes, quickly people should respond whether you have got or still doing it, so that I can take up another one.
Got, sir.
So Akshata completed. What about Chaitra?
So scope is not opening, sir, when we double click on it. And also same thing.
See, one ಸರ್ತಿ ಕ್ಲಿಕ್ ಮಾಡ್ಬೇಕು ನೀವು ಎರಡು ಮೂರು ಸರ್ತಿ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ Simulink will be slow. ಸಿಸ್ಟಮ್ ಹ್ಯಾಂಗ್ ಆಗಿಬಿಡುತ್ತೆ. ಸ್ವಲ್ಪ ಆ ಹಿಸ್ಟರಿ ಎಲ್ಲ ಡಿಲೀಟ್ ಮಾಡಿಕೊಳ್ಳಿ, ಸ್ವಲ್ಪ ಸಿಸ್ಟಮ್ ಫಾಸ್ಟ್ ಆಗುತ್ತೆ. Maybe in the desktop you should not keep many things. What people will do, everything they keep on desktop. So shall I take up the next one? Yes, Gana, Gagana, Ritu. See, every time ಎಲ್ಲರದು ನನ್ನ ಹೆಸರು ಕರೆಯಕ್ಕಾಗಲ್ಲ, ಹೇಳ್ಬೇಕು ನೀವು ನಿಮ್ಮ ಕಡೆಯಿಂದ. ಆಯ್ತಾ? ಮಾಡಿದ್ದೀನೋ ಮಾಡಿಲ್ವೋ ಏನು ಹೇಳಿದ್ರೆ ಏನು ಗೊತ್ತಾಗುತ್ತೆ ನನಗೆ. ಎಸ್ ಆರ್ ಅಂದ್ರೆ ಬಂದದೆ ಅಂತ ಅರ್ಥನಾ? ಗಾನ ಅಂಡ್ ರಿತು. Aman Sharma, MATLAB not working. Yes, shall I take up the next one? Trouble alliರೋ ಹಂಗೆ ಇರ್ತೀರಾ. ಓಪನ್ ಆಗಲ್ಲ ಅನ್ನೋರು ಓಪನ್ ಆಗಲ್ಲ. ನೀವೆಲ್ಲ ಡೆಸ್ಕ್ಟಾಪ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡಿದ್ರೆ ಹಂಗೇನೆ ಆಗೋದು. ಎಸ್ ಆದಿತ್ಯ, ಗೌತಮ್, ಸುಷ್ಮಿತಾ ಬಂತ ನಿಮಗೆ?
ಇಲ್ಲ ಸರ್, ನಾನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ.
ನೀವು ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಅಪ್ಪ ಆಯ್ತು.
ಇನ್ನು ಸೇಮ್ ಬರ್ತಿದೆ ಸರ್.
ಏನ್ ಸೇಮ್ ಬರ್ತಾ ಇದೆ? ಅವ್ರಿಗೆ
ಸರ್ ಮೂರು
ನಿನಗೆ
ಸರ್
ಗೌತಮ್ ನಾನೆಲ್ಲ ಓದ ಅನ್ಸುತ್ತೆ. ವಾಟ್ ಆದಿತ್ಯ, ಸ್ಟಿಲ್ ಯುವರ್ ಗೆಟಿಂಗ್ ಸೇಮ್ ಥಿಂಗ್?
ಎಸ್ ಸರ್, ಸೇಮ್ ಅದೇ ಬರ್ತಿದೆ.
ಅದೇ ಸೇಮ್ ಬರುತ್ತೆ, ಬರಕ್ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ನೀವು ಸ್ಕೋಪ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ಸೆಟ್ ಮಾಡಿದ್ರೆ ಬರುತ್ತೆ. ಇದು ಹಲೋ ವಿಧುಶೇಖರ್, ಹೌದಾ ಅನ್ಸುತ್ತೆ ಆರಾಮ ಕಾಫಿ ಗೀಫಿ ಕುಡ್ಕೊಂಡ್ಬರಕ್ಕೆ. ಯಾಕೋ ಎಸ್ ಸರ್ ಅಂತ ಹಾಕ್ತಿದ್ದಾರೆ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ. ಏನ್ ಮಾಡಿದೀವಿ ಬಂತೇನೆ ಔಟ್ಪುಟ್? ಇನ್ಯಾರಿದ್ದಾರೆ? Yes, what about Deepak Tiwari? Deepak Tiwari, then Keshav Venkatesh, Keshav Kanya.
I'm trying in online MATLAB, sir.
So ಆಯ್ತಷ್ಟೇ ಆನ್ಲೈನ್ ಮ್ಯಾಟ್ಲ್ಯಾಬ್ ಅಂದ್ರೆ ಮುಗೀತು.
So online MATLAB, it is a bit slow, so I'm trying that.
ಇದು ಸಿಸ್ಟಮ್ ಹೆಂಗಾಯ್ತದೆ ನಿಂಗ? ಹೆಂಗಾದ್ರೆ ಹೆಂಗೆ? ವಾಟ್ ಅಬೌಟ್ ರಕ್ಷಿತಾ? ಶಿ ಲೆಫ್ಟ್. ಕುಸುಮಾಕರ್ ಪಾಟೀಲ್ ಏನು ಅಟೆಂಡೆನ್ಸ್ ತಗೊಂಡಾಗ ಬಂದಿಲ್ವಲ್ಲ, ಈಗ ಬಂದಿದೀಯಾ? ಕುಸುಮಾಕರ್ ಪಾಟೀಲ್
Yes, sir.
ಏನ್ ರಾಜನ್ ಮೊಮ್ಮಗ ಏನೋ ನೀನು? ಇವಾಗ ಬಂದಿದ್ಯಾ, ಏನ್ ಮಾಡ್ತಾ ಇದೀಯಾ? ವೈ ಯು ಆರ್ ಜಾಯ್ನ್ ನೌ?
ಸರ್ ಅದು ಇಂಟರ್ನೆಟ್ ಇತ್ತು ಸರ್ ಅಷ್ಟೇ.
ಹೇಳಕ್ ಅಷ್ಟೇ, ಇಂಟರ್ನೆಟ್ ರೀಸನ್ ಅಷ್ಟೇ ಅಲ್ವಾ? ಹೇಳಕ್ಕೆ ಇಂಟರ್ನೆಟ್ ರೀಸನ್ ಅಪ್ಪ. ಕಲಿಯೋ ಇಷ್ಟ ಇದ್ರೆ ಕಲ್ತು ಬಿಡ್ತೀಯ, ಕರೆಕ್ಟ್ ಟೈಮಿಗೆ ಜಾಯ್ನ್ ಆಗಿ ಮಾಡಿ ತೋರಿಸ್ತೀಯ. ಇಲ್ಲ ಅಂದ್ರೆ ಹಿಂಗೇನೆ ನೋಡಿ, ಒಬ್ಬರಿಂದ ಕ್ಲಾಸಿಗೆ 4 ಜನ ಇರಲ್ಲ. ಈ ತರ ಎಷ್ಟು ತಲೆ ಬಿಸಿ ನಮಗೆ. ಕಲಿಬೇಕಲ್ಲ, ಕಲಿಯೋ ವಯಸ್ಸಲ್ಲಿ ಕಲ್ತು ಬಿಟ್ರು ಆಮೇಲೆ ಕಲಿಯಕ್ಕಾಗಲ್ಲ. ಈ ಏಜಲ್ಲಿ ಯಾಕೆ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ತೀರಾ? ಲರ್ನ್ ಪ್ರಾಪರ್ಲಿ, ಸ್ಪೆಂಡ್ ಟೈಮ್, ಬಿ ಅಟೆಂಟಿವ್. ಏನಾದ್ರು ಮಾಡ್ತಾ ಇದೀಯಾ ಏನಿಲ್ವಾ?
ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಅದೇ ಕಂಪ್ಯೂಟರ್ ಒಂಚೂರು ಹ್ಯಾಂಗ್ ಆಗಿತ್ತು, ಮತ್ತೆ ರೀಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೀನಿ.
ನೋಡಿ ಹಿಂಗಾದ್ರೆ ಹಿಂಗೆ ಹೇಳೆ, ಕಂಪ್ಯೂಟರ್ ಹ್ಯಾಂಗು, ರೀಸ್ಟಾರ್ಟು. ಕೇಶವ್ ಕನ್ಯಾ ಲಾವಣ್ಯ ಅಲ್ಲಿಗೆ ಆಗ್ಬಿಟ್ರು, ಸುಮ್ಮನೆ ಆಗ್ಬಿಟ್ರು ಲಾವಣ್ಯ. ಅಶ್ವಿನ್ ಏನ್ ಮಾಡಿದ? ವಾಟ್ ಲಾವಣ್ಯ ಗಾಟ್ ದ ಔಟ್ಪುಟ್?
ಇಲ್ಲ ಸರ್, ಮಾಡ್ತಿದ್ದೀನಿ.
ಯಾವಾಗ ಮಾಡ್ತೀರಾ ಹೇಳ? ಹಿಂಗಾದ್ರೆ ಇನ್ನು ಮೋಸ್ಟ್ಲಿ ಜನವರಿಗೆ ನಿಮಗೆ ಲಾಸ್ಟ್ ವರ್ಕಿಂಗ್ ಡೇ ಹಾಕ್ಬಾರ್ದು ಅವರು, ಮಾರ್ಚಿಗೆ ಹಾಕ್ಬೇಕನ್ಸುತ್ತೆ ಅಲ್ವಾ? ಈಗ ಸಿಸ್ಟಮ್ ನೋಡಿದ್ರೆ ಮಾರ್ಚಿಗೆ ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಲಾಸ್ಟ್ ವರ್ಕಿಂಗ್ ಡೇನ. ಇಟ್ ಈಸ್ ಎ ಮ್ಯಾಟರ್ ಆಫ್ 10 minutes. Okay, so simple circuit. We have not made any complex. 4 ಬ್ಲಾಕ್ಸ್ ಇಲ್ಲ, ಅದನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿ ಸಿಮ್ಯುಲೇಟ್ ಮಾಡಿ ಔಟ್ಪುಟ್ ನೋಡ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಕಷ್ಟ. Okay, I will take up the next one. You people can take the screenshot of that circuit. Try in home. Okay, I'm showing you the screen. This one circuit. You can take the screenshot of this. This is your DPSK circuit. And as well as waveform. Both you can take screenshot and try. Maybe you can present or you can put it in the GCR. Okay. So shall I take up the next one?
Yes, sir.
Yeah. So I will take up next is TDM. Okay. Yeah, this is a TDM circuit. I will tell what it is.
Sir, you are not presenting.
Yes, hope you all know what is TDM, right? Anyone can say quickly from your side? I would like to hear what TDM is. Yes, quickly, people can say what is TDM. Yes, Aditya Datta or Gautam, you can stop your sharing. Yeah. Yes, quickly, anyone can say what is time division multiplexing. So both time division multiplexing and demultiplexing are supposed to do. That is one experiment. ಎಸ್ ಮಾತಾಡಬೇಕು ಸ್ಟೂಡೆಂಟ್ಸ್ ಹೇಳ್ಬೇಕು ನಿಮ್ಮ ಕಡೆಯಿಂದ ಟೈಮ್ ಡಿವಿಷನ್ ಮಲ್ಟಿಪ್ಲೆಕ್ಸಿಂಗ್ ಅಂದ್ರೆ ಏನು? ಏನು ಹೇಳಲ್ವಾ? ಎಸ್ ಬಾಯ್ಬಿಟ್ಟು ಮಾತಾಡ್ರಿ. ವಾಟ್ ಈಸ್ TDM ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ವಾ? ಏನು ಅವಮಾನ ರೀ ನನಗೆ. ಹೊರಗಡೆಯಿಂದ ಇನ್ವರ್ಟೆಡ್ ಟಾಕ್ ಕರೆಸಿದ್ರೆ ಮ್ಯಾಟ್ ಲ್ಯಾಬ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಎಸ್ ಅಂತಾನೆ ಹೇಳಕ್ಕಿಲ್ಲ ಧೈರ್ಯ. ವಾಟ್ ಈಸ್ ದಿಸ್? ಐ ಫೀಲ್ ಶೇಮ್ ಟು ಸೇ ದಿಸ್ ಆರ್ ಆಲ್ ಅವರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಂತ. ಆಪೆ ಬಂದ್ರೆ ಏನು ಅಂತ ಹೇಳಲ್ಲ ಹೊರಗಡೆ ಅವ್ರಿಗೆ. ವೆನ್ ವಿ ಇನ್ವೈಟ್ external guest, if they ask something, you people are not opening up your mouth. If you are not opening up your mouth, what it indicates? So silence is your answer. Being silent, you show your maturity and greatness. ಯಾಕೆ ನೀವು TDM ಅಂದ್ರೆ ಗೊತ್ತಿಲ್ವಾ? ಓದಿಲ್ವಾ ಇಲ್ಲಿವರೆಗೂ? ಟೈಮ್ ಡಿವಿಷನ್ ಮಲ್ಟಿಪ್ಲೆಕ್ಸಿಂಗ್ and frequency division multiplexing. These are the concepts which I have only thought. ಸಿ ಪಾಠ ಮಾಡಿದ ಟೀಚರೇ ನಿಮಗೆ ಕೇಳಿದ್ರೆ ಹೇಳಲ್ಲ ಅಂದ್ರೆ ಬೇರೆ ಟೀಚರ್ ತಗೊಂಡ್ರೆ ಹೆಂಗೆ ಅರ್ಥ? Yes, come on, speak out. No, you can't define what is TDM. ಏನು ವರ್ಸ್ಟ್ ಇದ್ದಾರೆ ನೀವು. ಎಸ್ ನೋ ಅಂತಾನೆ ಹೇಳಕ್ಕಾಗಲ್ವಲ್ಲ ನಿಮಗೆ, ಗೊತ್ತು ಗೊತ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿ. ಸುಮ್ಮನೆ ಮೂಕರ ತರ ಕೂತ್ಬಿಟ್ಟಿದ್ದೀರ ಅಷ್ಟೇ. ಎವ್ರಿ ಟೈಮ್ ಹೆಸರು ಹಿಡ್ದೇ ಕರೆದು ಮಾತಾಡ್ಸ್ಬೇಕಾ ನಿಮ್ಮನ್ನ? ಯಾಕೆ ನಿಮ್ಮಷ್ಟು ನೀವು ಮಾತಾಡಕ್ಕಾಗಲ್ವಾ? ನೋಡಿ ಯಾರು ಏನು ಮಾತಾಡಲ್ಲ, ಇಷ್ಟೆಲ್ಲ ಬೈತಾ ಇದ್ರು. ಹಿಂಗೆ ಕೇಳಿಸ್ಕೊಂತೀರಾ ಇಲ್ಲ ಆರಾಮ ಕಾಫಿ ಟೀ ಕುಡ್ಕೊಂಡು ಸ್ನ್ಯಾಕ್ಸ್ ತಿನ್ಕೊಂಡು? ಅಲ್ವಾ? ಹಾಗೆ ಅನ್ಸುತ್ತೆ. ನೀವು ನೋಡಿದ್ರಿ ಏನು ರೆಸ್ಪಾನ್ಸ್ ಇಲ್ಲ ಅಂತಂದ್ರೆ I don't know how many of you are really interested in learning. So you people don't want to say what is TDM. ಹೇಳಿ ಸುಷ್ಮಿತಾ.
Sir, it is a method of transmitting and receiving independent signals, sir, irrespective of over a common signal path,
Okay.
an alternating pattern.
Yeah, how do you multiplex the different signals over a common channel? That is what important. Now, time division multiplexing means
Using filters, sir.
ಅದೆಲ್ಲ ಹೇಳ್ಬೇಡ್ರಿ ಫಿಲ್ಟರ್ ಅದು ಇದು ಅಂತೇಳಿ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳಿ ಕ್ಲೀನ್ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಸಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡಿವಿಷನ್ ಮಲ್ಟಿಪ್ಲೆಕ್ಸಿಂಗ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಟೈಮ್ ಡಿವಿಷನ್ ಮಲ್ಟಿಪ್ಲೆಕ್ಸಿಂಗ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ ಹೇಳ್ಬೇಕು ಸಿ 10 users are there. How
Yes,
all those 10 users will be able to use the same channel ಅನ್ನೋದು ಹೇಳ್ಬೇಕು.
using a multiplier and demultiplier, sir, through a hydron.
ಮಲ್ಟಿಪ್ಲೈರ್ ಡಿಮಲ್ಟಿಪ್ಲೈರ್ ಹೇಳ್ಬೇಡಿ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳಿ ಹೆಂಗೆ ಸಿ 10 users are there ಅಂತ ಹೇಳಿದೆ ಅಲ್ವಾ 10
Yes, sir.
people are there. All 10 people has to use the same channel. Okay. So is it possible to use the channel all the 10 people at the same time? Are they going to use the channel at different intervals of time? That is important, right?
Yes, sir.
That is the core concept. Now, is it possible to say? ಅರ್ಥ ಆಗಲಿಲ್ಲ ನಿಮಗೆ.
Yes, sir, I understood where.
Yeah, I have a single channel. Maybe its bandwidth is say 10 kilohertz. Let me think. Okay, I have 10 people. Okay, by doing this time division multiplexing, if I say the frame size is 10 milliseconds, okay, each one of them can talk for a period of 1 millisecond. Okay, so with that 10 people, so each one can talk 1 millisecond, right? So 10 millisecond will be the frame size. So after 10 millisecond, again you will get a chance to speak. Like that. That is what the concept of time division multiplexing. Okay, all will be using the same channel, but they will be talking at different time intervals.
Yes, sir.
Since it is in terms of microseconds, we don't feel like we are transmitting our signal by leaving a gap. Okay, it will be a continuous. Okay, so let me take an example of how we can multiplex two signals and transmit over the channel, and again how do we recover that at the receiver side. I hope you can recall. So you need to visualize the block diagram of time division multiplexing. That is, there will be a commutator switch. Okay, so that commutator switch will be taking the samples from each of the users. Okay, then we get PAM signal transmit over the channel. Then at the receiver side, again there will be a decommutator. Okay, again that decommutator will be giving the samples to the respective users. So this commutator and decommutator has to be synchronized. Okay, if the synchronization between commutator and decommutator is proper, then only we will be able to achieve a proper time division multiplexing signal. So this is theoretical aspects. So here we are not going to have the block diagram in that same fashion. We don't say this is a commutator, the decommutator is a channel. Okay, so just let me show how it is done. Then you can parallelly do it and check. Okay, so this is my both time division multiplexing and as well as demultiplexing. So this is a signal generator. Okay, I have taken two signal generators. Hope you're able to see. Then this is my clock. Okay, this is my clock. Hope is this clear? Just go to library browser. Okay, just write in that search signal generator, you will get it. Okay, it is different from sine wave generator. Okay, signal generator means you'll be able to get different waveforms there. I can select any of that.
Sir, you
Signal
are not
generator.
visible, sir.
Huh?
Yes, sir. Your screen is not visible, sir.
My screen is not visible.
Oh, no, it's visible. It's visible,
Visible,
sir.
no.
Actually, you're using two accounts, I think. We need to
Oh.
pin on another account.
Sir, you
Sir,
need to resume the presentation, sir. It has been paused. You need to resume it, sir.
Now visible, sir.
Okay. Anyway, I resumed. Yes, now is it possible to see?
Now it's fine, sir. Now it's fine, sir.
Fine, no. I said signal generator. Okay, go to library browser. Just in search, no, you write signal generator. You will get that. Hope able to see that signal generator, no? Take signal generator. Take two signal generators, okay? I will tell what parameters to check. If you click on that, you'll be able to set amplitude and frequency. And even you can select waveform. Okay, so I have selected sawtooth. You'll be able to select sine, square, sawtooth, random. So I have selected sawtooth. Is that fine? Apply, then okay. Yes, is that fine?
yes, sir.
Yes, sir.
Okay, take two, even when you take one, no, you can do that control C, control V. Okay, so two signal generators. First one I set it sawtooth. Second one I am setting it to sine. So second one, double click on that. Waveform, you can select sine. Okay. Time use simulation time. I kept amplitude as 2 volts and frequency I made here 2 into pi into 2. I can select hertz also, radians per second. So here I have selected radians per second. Okay. Then this clock also you will get. Go to library only. You just write clock. Okay, CLOCK. Clock. You will get that. Yeah. So when you just type clock, you take this one, Simulink extras. One is there, no? That clock you take. Not the first one here, clock is there, then digital clock is there, not that. Last one is there, no? Hope you are able to find. Simulink extras, flip flop, slash clock is there, right? There is a digital clock, you can take that. Yes, got it?
Yes, sir.
So double click on that and period only you have to set. So I have set period is 2. So it is a digital clock, okay? So output is set to 1 for the first half of the period. Okay? Fine. Then you can take how many switches? 1, 2, 3, 4, 5 switches you can take. Means you can take one switch, then you do control C, control V 5 times. You'll be able to get those multiple switches. Okay? Hope understanding.
Yes,
Take
sir.
switch. Yeah, take switch. You can make control C, control V. Okay, so you can arrange the switches in this fashion. Then another component is this one is delay. Okay, transport delay it is. Okay, so transport delay also you will get from that point only. Go to library, just make a transport delay. Just write transport delay. Yeah, if you write transport delay, you'll get so many things are there. Okay, entity transport delay, then just transport delay is there, variable time delay, variable transport delay and all. In that you can take transport delay. Yes, got it?
Yes, sir.
So transport delay you take. So I think transport delay also you need 3. Then you can take scope. With a single scope only, you can display everything. To make it simple, I have displayed first a TD, means signals from each of these signal generators, then output of these switches in one scope, then TDM signal in another scope, then a demultiplexer signal in another scope. That is why I have taken 3 different scopes. In one scope only we can do. Okay. Just to get a better clarity, I have taken 3 different scopes. And you can set for all the switches, the threshold value is 0.5. Okay, threshold value is 0.5 and make this enable zero crossing detection. Put the tick mark on that. Done. Yes, is it done? Yeah, see here it is connected for this scope. Okay, first point is connected to first signal generator. Then second port is connected to second signal generator. Then third one is connected to the output of the first switch. Then for the fourth one, it is connected the output of the means from second switch I have a delay element, right? So output of the delay element is connected to the scope. So one I am feeding directly, another one I am feeding with the delay. Okay. So with that, means one signal I am feeding directly, another signal I am feeding it with the delay. Okay. Hope this connection, don't feel that it is complicated. It's very simple. From signal generator, you connect it to first terminal of the switch. Okay, for the second terminal, you connect from this clock, digital clock. The third terminal is left blank. Similarly, for the second switch also, connect from the second signal generator to first terminal of the switch. Second terminal should be connected to clock. Okay, so whenever this clock is greater than 0.5, it will take the output of first signal generator. Like that. Then, similarly, from the second signal generator it will take with a delay. Okay, that will be fed to the third switch. Means output of the first switch is connected to the first terminal. Then output of this second switch delay element is connected to the third terminal of the switch, and the clock is connected to middle of the switch. Okay, so this is my output of the DPSK, TDM. Okay, the third switch output is TDM. That I connected to this scope. I can keep this scope here only, okay, to make it simple. Is that fine? So in this scope, you will be able to see the time division multiplexer signal. Then to do the demultiplexing, hope you are with me.
Sir, the switch
sir.
and transport delay have connected to the box, sir. Which one? What is that, sir?
Yavdu?
That plus switch and the transport delay have connected, no, sir. Is that adder or what?
You see, the output of the second switch is connected to the transport delay. Then output of transport delay is connected to the third terminal of the switch, or third switch.
Not this one, sir. The other side, right hand side.
Here,
Before
here,
switch.
here. Yeah,
Yes, sir.
this is for recovery. Okay, demultiplexing means output of this means TDM signal. This TDM signal I'm connecting it to two switches, one terminal of the two switches. Okay, for another terminal is connected to the clock. Okay, second terminal is clock. First terminal is TDM signal only for both the switches. Okay.
I asked that block, sir. What is
Yeah,
that?
this blocks is delay again.
The
See,
other one, sir.
transport delay only. It is
This
adder.
one.
You need to take this is adder. Okay, I am adding
Okay,
those
sir.
two signal. Yeah, this is adder. Okay, this is adder. So one I am doing with a delay, another without delay. TDM signal. Similarly for the download also. So again, I will be able to get back my original signal here from this scope. Is that fine? So in one stretch, we are doing everything. That is multiplexing and as well as demultiplexing. As I said, even in one scope only we can see. But for better clarity, I have taken 3 scopes. I make a large so that you'll be able to see that. Hope visible, na?
Yes, sir.
So everything I am making it big. I think this is fine. Okay, this size. Yes, is it done? Hello? Manila.
No, sir. Doing, sir. Done, sir.
Yes, done. So what output you were able to have simulated? Yeah, you can make the scope.
No, sir.
Huh? If you run it, already I've done scope this one. You can make that scope. See, first one is 4 windows, no? That's just x-axis, y-axis and all. Yeah, just I will show the output. Yeah, this is not that proper. Means I will make configuration. Okay, actually this is my sawtooth waveform. Okay, so this is my scope 1 output. Means I am able to see. I am going to see the signals from 2 signal generators, and then output from each of the switch. Okay, this is my sawtooth waveform first window. Then second window is my sinusoidal signal. Third window is output of the first switch. Okay, it will take only, means if I take this time duration, T1, T2, T3, T4 and so on for this also. So it will take T1 of first waveform. Then T2 is gap. Then T3 will come. Then T4 will be gap like that. Then this is my signal from the second window. That is from signal from the second signal generator. Okay, means at 0 to T1 it will be 0, then T1 to T2 I will get signal from second signal generator. Okay, hope you are able to understand what I am saying. Hello.
Yes, sir.
So this is how I make this is. Yeah. Hope understood now? This is my signal 1, this is my signal 2. So this is what till T1 I get signal 1, T2 gap. Okay, in the gap of T2 I get second signal. Okay, then at T3 first signal, here gap, then T4 the second signal, like that. So alternate, right? Since I have only 2 signals, if I take T1, T2, T3, T4 and all, T1 message signal 1, T2 message signal 2, then T3 message signal 1, T4 message signal 2, like that. Okay, alternate time period I get the message signal 1 and 2. Hope understood this point. Yes, people are not saying yes.
Yes, sir.
If you want, you can make color change so that yeah, let me change the color of third this one switch. Let me make it some different color, red one. Hope you're able to see now that color. Then fourth one, something different color. Let me make it blue. Okay. Accordingly, I will make it first one as red. So it is a self-explanatory. So first one is red. Okay. Then I make it second one is blue. Okay. Yeah. Hope you able to understand, na? Message 1, message 2. So third window is what? Only I get message 1 with a gap. In T1 time interval, I get message 1, T2 gap, T3 message 1, T4 gap, T5 message 1, like that. Then fourth window, in T1 gap, T2 I get message signal 2, right? Like that. So what will be the TDM signal? The mixing of these two, right? So first I get message signal 1, then message signal 2. ಬೆಳಿಗ್ಗೆ 46 ಈಗ ಅಲ್ಲೊಂದು 5 ಹುಡುಗರು ಇದ್ದಾರೆ ಲ್ಯಾಬಲ್ಲಿ ಇಲ್ಲಿ 2 ಒಂದು 5 7 3 10 44 ಅಲ್ಲಿ ಆಬ್ಸೆಂಟ್ 44 34 ಅಂತ 34 ಪ್ಲಸ್ 2 ಅಲ್ಲಿ 2 ಇರೋದು 5 ಜನ ಹೋಗ್ಬಿಟ್ರು ಹೌದಾ ಮಾಡೋದ್ರ 40 ಆಗ್ತೀನಿ. Yes, able to understand, no?
Sir, I'm not getting the second window as proper.
What you are not getting, ma, Akshita?
not getting that second window as a proper sine wave.
Fine, no issue.
Proper sine wave, sir.
Yeah, that is with the scale. Okay. So here sinusoidal signal it is displaying properly. Na? You need to adjust the scale. I hope you return.
No, sir, even we can't make it out as a sinusoidal wave, sir. It's full coming as a
Sawtooth
sawtooth only. Can I present and show, sir?
No issue. You can try by yourself. Okay. Then let me complete this. Anyway, you have adjusted in the signal generator that time as 2 into 5 into 2, the frequency. And 2
Yes,
into
sir.
5 into 2, the radians per
Yes,
second you
sir.
select. Magnitude is 2 volts you have taken.
Yes, sir. I selected the
Yeah,
5
even in
second
this
only, sir.
scope, no, even in the scope also, you have to make a proper alignment. Okay, see here exactly it is displaying plus 2 volts and minus 2 volts, right? Magnitude. And little bit variations in this one, not an issue. But sawtooth, see, it is not going up to minus 4, right? Only plus 4, then minus 1 something. So that it all depends on adjustment. Okay, let's try to understand the concept, then you can.
No, sir, I'm getting completely different wave.
Huh? Yeah, you will get a
I'm
different
getting
shape if
completely
the
different wave, sir.
scaling is not proper in this scope. Okay, if you are able to make the proper alignment in the scope, you will get proper wave. Yeah, fine. This is one window. I will come back to that. Okay. Hope this is clear. The first point. Just I am displaying two message signals. So this is my signal one, and this is my another signal. First one is the SAR2, second one is the sine wave, and these are the other two windows are what I'm taking only at a T1 means T1, T3, T5, T7 is my message signal. One will come at T2, T4, T6, T8, and so on. I get the second message signal. So multiplexing is what combining these two. So that I will be able to see in the I think next window. Yeah, this is a demultiplexer signal. This one is the multiplexer signal. Okay. So at T1 I get sawtooth. At T2 I get the sine wave. Okay. Then again T3 sawtooth. T4 sine wave. Is this fine? That is the second scope. No, second scope.
Kind of waveform, sir.
Second scope you will be able to see this output. That is from here. If I go to circuit, now this is scope. Third switch is there, na? Third switch. This is a switch 1, switch 2. Then output of those two switches you're connecting to third switch, na? The output of the third switch will be your TDM signal, time division multiplexer signal. Yes, got this point? Here you will get TDM signal.
Yes, sir.
Okay, then rest is the demultiplexing. Okay, so here I have separated first one and second one. I'm just adding those two. So here in this scope, you will be able to see two different signals. That is, one is sawtooth, another is sinusoidal signal. So that also I can show. Hope you could see this. This is a multiplexer signal. Okay. Since I have taken different amplitude, message signal one is plus 4 volts sawtooth. Okay, and message signal 2 is 2 volts sinusoidal signal. I hope you will be able to see that right properly. Okay, then let me show the demultiplexer signal. Yeah, this is my demultiplexer signal. The first one is our sawtooth. Second one is my sinusoidal signal with a delay of 1 bit duration. I am getting the second signal. Okay. I am making same color what is done at the transmitter side. So that you will have that feeling. Okay, when compared to the message signal 1, the message signal 2 will be delayed by 1 bit duration. That is the difference. That's all. So rest all is hope this point is clear.
Yes, sir.
Yeah, if this is done, then only one more experiment is left out. That is line code generation. That I think we'll do by using MATLAB only, by writing a code. Okay, I think that I will complete in the next week. Is that fine?
Yes, sir. Sir, that part A record, this Simulink one, should we write theory and this screenshot and waveform we should put, sir?
Yeah, you can. You have to write for ASK, FSK, PSK, QPSK, DPSK, even TDM. The relevant theory to be written. Okay.
Okay.
ASK means what? ASK generation and as well as demodulation. That waveforms also. And then whatever the waveforms you get from your scope, you can take the screenshot of that.
What about circuits, sir?
Circuit, you write the Simulink circuit only. And yeah, since you have done this one only, you can write this one only now. Because if you write something else, then in tomorrow exam, what you will do? Whatever I have thought, you do it. Okay, that's what I say. And we cannot ask something else what we have not thought now. Isn't it? Since people have not come for offline, and it is not compulsion also, hence we are doing it simulation, do Simulink. You learn this properly, that will be more than enough. Okay.
Sir, can you upload recordings of
recording should, yeah, already all experiments I have given in the GCR, right? Yesterday, I think, yesterday, I kept all the experiments. So as of now, you have done only generation. No? You can upload generation circuit. Only demodulation, I will take up in another class. On that day, you can upload only the demodulation waveforms. That's all.
No, sir, we were asking about this class recordings which you are teaching now so that we can go back to it and look at it once.
Oh, recording, you want? Yeah, that I can share. No? I have shared Google Classroom, some of the sessions. I will share other sessions also.
We couldn't find it, sir. Can you please share?
GCR is there. In GCR, I have shared even in YouTube channel also for some of the labs. Okay, I will find out. Okay, I will find out and upload.
Yes, sir. Thank you, sir. Yes, sir.
Because here so much of time we are wasting in this one. No? That is why I might not have uploaded in the YouTube as a public. Okay, I will share in the Google Classroom all these windows recordings. That is fine, no?
Yes, sir. Yes, sir.
In Google Classroom, but people should update the report.
Sir, record can be written in any book, no, sir, not specifically record.
Yeah. A4 sheets you can write and see these are all the things what output you are getting from this scope. Not straight away you can. I think we have the option to save. If you go to file, that print preview will be there. Print to figure like that. Print option is there. Control P. You can save it as a PDF and you can upload that, right?
Yes, sir.
So far, whatever I have done, that should be completed. Okay. So TDM is done. All modulation techniques, generation part is done. Only line coding is left out. And one more is optical fiber communication experiment is there. That I think I will give the demo. Okay, video only I can show. So line coding and rest of the things I will complete in the next week. Next week also, we are combining the batches B1 and B2. Maybe either on Thursday or Wednesday I will have that. Okay.
Yes, sir. Sir, and about the open-ended, what you have posted, that should be done in Simulink or MATLAB?
Any you can use MATLAB, Simulink or LabVIEW.
Okay, sir.
If you are aware of LabVIEW also, you can use. Since I have not thought about LabVIEW, if you know, you can do it. Okay, I am not restricting people to do by using only this software. If you are able to do with different softwares, I am very happy. Even other than these, MATLAB or LabVIEW, any other software, if you know, if you are able to do it by using that also, fine. But it should be done independently. Okay,
Yes.
not just doing one person, taking from your friends and uploading by all others. If it is same, I will make 0 marks for the entire class. In that way, that is why I kept for every experiment some uniqueness. 2 marks, like that I kept, okay? So if you are not doing the program by yourself, if you are not showing uniqueness, then you will lose that marks. How many of you have uploaded your report? Part B completed?
Yes, sir.
Part A, how many have uploaded? How many experiments?
No, sir. Part A, we didn't know like what to write this because the other part we had code. So this one we wanted to ask you and then upload, sir.
Fine, but do it now. So it is a late, right?
Yes, sir.
I
We
have
finished.
done experiment title generation and detection. So as of now, I have done generation. You upload generation part. After it is detection part, you can upload the detection part.
Yes, sir.
Always you can append one page, right? But don't wait till the completion of all other things. Already 90% is done. Okay. So this line coding, you people should read and come. I will ask the questions. Okay. Only if you people are able to say what is line coding, what are the different types, then it is a matter of 10 minutes writing code. Okay. By that time, by the way, anybody can say what are the different types of line codings you have studied?
Unipolar, bipolar, Manchester.
Yeah, unipolar, polar, bipolar, and Manchester, right? So these are the 4 different types of line codes. And in that, again, we say NRZ and RZ, that is non-return to 0 and return to 0. So for this unipolar, polar, and bipolar, we'll do this both return to 0 and non-return to 0, and then see the Manchester coding. Okay, so simple logic. I think I will tell you the logic with the MATLAB code. Only hardly 5-6 lines code is there. You can have a look also and able to understand and do it. Fine. Okay, is that fine? So, Keshav Venkatesh, can you say what is unipolar line coding? Unipolar means what? Keshav.
Yes, sir.
Yeah, what is unipolar, man? Unipolar line coding. Unipolar. Name only says uni means what?
So uni means it should be same either positive signal or negative signal. So if it
Yeah, in that way, unipolar signaling means how do we define? It has only one polarity, right? So 0 will be represented by no pulse. Then binary 1 will be represented by a positive pulse. Okay, having a magnitude of, say in general, we say A volts, that the value of A can be anything. It may be 2 volts, 3 volts, or 5 volts. Is that fine? Unipolar, that is NRZ. Non-return to 0 means it will occupy the entire bit duration. The pulse will occupy the entire bit duration. That is non-return to 0 means it will not come back to 0. If it is high, it will be high for the entire bit duration. Okay. Return to 0 means it will be high only for half of the bit duration. So another half of the bit duration it comes back to 0. That one we are calling it as return to 0 signaling. Understood? Unipolar return to 0 means Binary information 0 will be transmitted with no pulse. Binary information 1 will be transmitted by a pulse having an amplitude of plus A volts. In case of return to 0, the pulse will come back to 0 after half of the bit duration. Okay, means it will be I only for half of the bit duration. So another half of the bit duration it will become 0. In case of NRZ, it will be I for the entire bit duration. Okay. Similarly, polar means what? Aditya Datta, can you say polar signaling? Aditya Datta. Yes, so what about Madhura? Yeah, tell me, Aditya Datta.
Sir, in polar signaling, high data is represented by positive and low is represented by negative pulse.
Yeah, you should tell in terms of binary 0 and 1. 0 will be represented by a negative pulse, 1 will be represented by a positive pulse. Okay. So that is NRZ. Return to 0 means so 0 will be represented by a negative pulse for half the bit duration. So another half the bit duration will come back to 0. Similarly, binary 1 will be represented by a positive pulse for half of the bit duration. So another half of the bit duration comes back to 0. Okay. Then bipolar means, yes, Lavanya, can you say bipolar? See, bi means what? Two, na? There will be two polarity for one particular type of binary information. Okay, another binary information will be transmitted with no pulse. Means in case of bipolar signaling, binary 0 will be transmitted with no pulse and binary 1 will be transmitted. Once it will be transmitted with positive pulse, another time it will be transmitted with a negative pulse. Okay, means if I have a sequence of ones, the first one will be transmitted by a positive pulse, the next one will be transmitted by a negative pulse. Again, next one will be transmitted by a positive pulse, and further one will be transmitted by a negative pulse, like that. So it is also known as alternate mark inversion because we mark the symbol 1 alternatively by positive and negative pulses. So that is why it is called alternate mark inversion, AMI signaling. And it is also known as pseudo-ternary signaling. So that is about bipolar. Okay. Then Manchester. Yes, Shreyas, can you say what is Manchester? Shreyas.
Sir, I've forgotten, sir.
What about Vido, Vandana? Some people have left already. 27 is there, including me. Yes, Vandana, can you say what is Manchester coding?
Manchester line coding, the encoding of each data bit is either low or high, low than high or high than low.
You tell how binary 1 will be transmitted, how binary 0 will be transmitted. So in Manchester line coding, binary 0 will be transmitted by, for half of the bit duration, it will be a negative pulse. Another half of the bit duration will be a positive pulse. Okay, binary 0 will be transmitted by what? Half of the bit duration, negative pulse. Another half of the bit duration by a positive pulse. Similarly, the binary 1 will be transmitted by a positive pulse for half of the bit duration, another half of the bit duration by a negative pulse. So in every bit duration, there will be a transition. Okay, that is from negative to positive and positive to negative. depending upon the binary data. Okay, for every half of the bit interval, there will be a transition. That is why it is called self-synchronization clock. Okay, hope understood?
Yes, sir.
Yeah, binary 0, I said it will be transmitted by a negative pulse for half of the bit duration, another half of the bit duration by a positive pulse. Similarly, binary 1 will be transmitted by a positive pulse for half of the bit duration and another half of the bit duration by a negative pulse. So I think I have given enough theoretical information as a revision. Next week I will straight away start the coding. Okay, of this whatever the line codes we have discussed so far. Unipolar, polar, bipolar, and Manchester. In the meantime, you people can also explore, okay, how that can be done by using MATLAB code. Then it becomes easy. Is it possible to do that?
Yes, sir.
Yes, ಅಂತೀರಾ ಬಟ್ ಏನು ಮಾತಾಡಲ್ಲ. Okay, with this, let me sign up for today. Okay, or if you have any questions, you can ask. Otherwise, I will sign off. So you people should complete